Hello ladies and gentlemen, in this video we talk about how to build smart port with beyond 5G. Exports from Malaysia have increased rapidly in recent years, hence an efficient port is more important than ever. A smart port is a port that enhances its efficiency using technologies like big data, artificial intelligence, and the Internet of Things. A smart port consists of smart container chips. These chips are embedded with many IoT sensors that send huge amounts of information to the smart port's data center. This allows the chips to plan where to dock in advance. Beyond 5G refers to the next generation of wireless communication technology, such as 5.5G and 6G. While B5G has not yet been launched, large corporations like Qualcomm has begun designing it. B5G offers 10 times lower latency compared to 5G. B5G can achieve a data transfer rate of 1 TB per second. B5G will also revolutionize the Global Positioning System, or GPS. The accuracy of GPS is greatly improved with only 1 cm of error of estimated location. B5G's GPS uses 3-dimensional design that it can determine your height above or below sea level. So how is the improvement achieved? B5G uses device-to-device communication. In 5G, for a device to communicate with another device, it must send electromagnetic waves to a cellular tower, and the tower will forward the message to the receiver. In B5G, mobile phones send and receive electromagnetic waves to each other directly. Any device between the sender and receiver will act as a router to help forward the message. If no nearby device is available, the cellular tower will be used to relay the signal instead. D2D communication allows smart ships to directly communicate and estimate distance between each other. In this case, ship A tells ship B that it is turning right, so ship B can prepare to slow down or change direction. With D2D communication, automatic driving smart ships will become very reliable.
With the higher usage of D2D connections in B5G, we need to provide the necessary infrastructure to ensure that B5G is reliable and its quality of experience stays high. With B5G, we are required to have a larger and better quality service for our connections. It becomes vital for us to have a network infrastructure that is able to transmit high data rates with high reliability while still maintaining low latency. So, why the need for such high requirements on our networks? We could expect an even larger number of devices to be interconnected in the future, and with Internet of Things, artificial intelligence, and automation becoming more mainstream, we need to accommodate these devices with the use of the B5G network. We are able to achieve this target through the upgrade and modifications of the physical layer. For the physical layer, we have to modify our wires or wireless networks to allow for larger quantities of data to be transported around. This either through increasing the amount of bandwidth or using more channels in our wired technology, or with new Wi-Fi or cellular technology and using higher spectrum wave, we can allow for higher bandwidth for wireless devices.
Now moving on to routing in beyond 5G. What is routing? Routing is the process of performing a network path selection that should generate the most effective route for data to be transmitted from its source to its destination device. When routing in a smart port, with the increase in network demand and quick decisions made in the smart port, data must be ensured it travels without any packet loss and arrives at its destination fast. But if done incorrectly, there are mainly 2 causes of ineffective routing. First being route flapping, which is when a router constantly fluctuates within a short period of time, and degraded quality of service, which is based on degradation of real-time and non-real-time data. Routing is achieved with the help of Internet of Things or IoT which enables all devices in the network to be connected via the internet and allowing them to communicate together, which also means device-to-device communications. With D2D communications, it helps with catering and providing reliable network stability with many different devices in a network. In other words, this technology would be helpful with routing in a smartphone. But if done incorrectly, the quality of service performance would be poorer than the performance of a traditional cellular network.
Moving on, the energy efficient mechanism on beyond 5G. How could B5G improve on the operational expenses and the environmental costs? 5G technology is proven to be more energy efficient with the help of ultra-lean design, which minimizes the power consumption rate of the base station by only transmitting data when it is necessary. Meaning to say, when no data is being transmitted, the 5G wireless cell will automatically shut down, or rather be placed in a sleeping mode. Speaking of base station, small cells. They are a new technology which was designed using 4G's macro cell as a reference. Small cells are much smaller in size, more power efficient, highly cost effective, and easy to implement. There are 3 types of cells: small cells, femtocells, and picocells. Each has its own usage and purposes. However, all 3 cells are capable of handling high data rates while ensuring low latency. All thanks to its small size technology and designed to serve only a specific area. The base station now has a much lower power requirement compared to its predecessor. With B5G technology, it can transmit data signals and power simultaneously to IoT devices. This is extremely helpful for a smart pod that consists of so many IoT equipments. With thanks to millimeter wave technology that has wireless power transfer capability. How it works is, there are 2 modes. One is receiving, another is transmitting. When it is in receiving mode, a power signal will be sent to the device to activate the IoT device. Once the device is activated, it will enter transmission mode and sends a 5G signal back in the same direction from which it initially received. With this, no more separate power source is needed, helping to achieve a greener smart pod.
A smart pod will make use of a massive amount of sensors and wireless devices where it required a high data transmission rate and low latency. In order to achieve this, we can add an additional layers in the OSI model called the service layer. In the service layer, it consists of 3 enhanced capabilities of 5G. The 3 enhanced capabilities of 5G are enhanced mobile broadband, massive machine types communication, and ultra-reliable low-latency communications, which supports 3 use cases each with different demands on data throughput, reliability, latency, and large connection. Each of them suits different use cases in smart pod. For example, we can use massive machine types communication for intelligent automation services in smart pod use cases. Enhanced mobile broadband for VR services. Ultra-reliable low-latency communications for smart guided vehicles when the present 4G network cannot match the low-latency needs of smart vehicles, but the B5G network is able to achieve the requirements.
The final part that we are going to discuss in this video is congestion control. So imagine congestion control as a solution to solve the massive traffic problems that we usually experience on the road. Similar to that, packets will also be congested due to the overwhelming requests, especially in industries like smart pods that have to process big data. To counter that, we have to implement congestion control, which happens in the transport layer of the OSI model to ensure the stabilization of the network, acceptable packet loss ratio, and efficient resource utilization. Congestion control is essential when it comes to smart pods to ensure the productivity and efficiency of the task. Our main 2 targets for congestion control is low latency and higher throughput. We highly recommend the usage of BBR, bottleneck bandwidth, and round-trip time, which was developed by Google in 2016 and have been implemented majorly in YouTube as well as Google. But how does it work? BBR works by observing how fast a network is already delivering traffic and the latency of current round trips. It then uses the data as input to packet pacing heuristics that can improve performance. Older algorithms oscillate in delay and throughput because they more aggressively stop packet transmission or more cautiously resume it in response to packet loss detection. Contrarily, BBR measures round-trip times to assess congestion and offers better, more reliable throughput while simultaneously enhancing latency. BBR evidently produced throughput improvements of up to 22% across many networks and locations, and a 40% increased latency improvements.
The future of B5G will bring about a revolutionary change to how our devices are connected at a large scale. With these newer technologies, our network will be changed drastically, from efficiency to connection quality to connection protocols. These improvements will allow us to have a lower congestion, faster data rates, and better quality of network while having better power efficiency. With these benefits, smart pods and its capabilities will become achievable, allowing us to have a large-scale automation viable in usage. Smart pods will be the next step in how we live our life, modified in both our homes and our workplaces. From IoTs and smart devices in our house, to automation and artificial intelligence in our workplace, smart pods will link us more together at an even faster rate, making us more efficient and helping us advance as a nation.
Thank you for watching this informational video on how Beyond 5G has made building smart port possible. We hope you have enjoyed and learned something new today.